Die Falcon 9 von SpaceX bringt mit der Cygnus-Mission 3,7 Tonnen zur ISS. Die Mission mit der Bezeichnung NG-20 startete vorgestern vom Space Launch Complex 40 der Cape Canaveral Space Force Station in Florida aus. Bei dieser Mission, die Teil des Commercial Resupply Services 2 Vertrag der NASA ist, handelt es sich nicht um einen routinemäßigen Versorgungslauf. Cygnus transportiert über 8.200 Pfund, also 3,7 Tonnen rund, lebenswichtiger Vorräte, Ausrüstung und wissenschaftliche Experimente zu den Astronauten an Bord der ISS. Die Ressourcen sind für die Fortsetzung der wissenschaftlichen Forschung und die Instandhaltung der Raumstation von entscheidender Bedeutung. Nach ihrem geplanten Rendezvous mit der ISS am 1. Februar wird die Raumsonde bis zu 6 Monate lang an der Station gedockt bleiben und dort nicht nur Versorgung, sondern auch zusätzliche Dienstleistungen erbringen. Freut euch nun auf das Dockingmanöver an die ISS. Viel Spaß dabei!
Already talked about who is supporting this operation here in Mission Control Houston under the direction of Flight Director Diane Daly. We know that we've got the Dulles control room too, keeping an eye on things. Our Capcom today is Alex Lankos, and he's going to be serving as our Capcom speaking to the crew. So if you hear that voice there, he is on the pink on your screen. So if you see a voice talking to the crew back and forth, confirming that they have good visuals of the spacecraft, that will be the voice of Lankos. Meanwhile, up at the space station, it will be NASA astronaut Laurel O'Hara inside the space station cupola, who will be at the controls of the robotic arm today. There she is, right on your left there. That's NASA astronaut Laurel O'Hara. She's going to be in the station's cupola. And NASA astronaut Jasmine Mogbelli, on the right of your screen, will be there for the assist. Two minutes remaining until the start of the approach initiation burn on the Cygnus cargo spacecraft. The vehicle is now within 2,000 meters of the space station. And the approach initiation burn has begun. Again, this is a thruster firing on the Cygnus spacecraft. It puts Cygnus on an intercepting path to arrive just below the space station. The approach initiation burn is still underway on the Cygnus cargo spacecraft. We're in a momentary handover between our satellites. In the meantime, we'll stick with live views of Mission Control Houston until we can get those live views back. Should be any moment now. The station has what's known as a common berthing mechanism. It's an attachment system used to mate segments of the U.S. side of the space station to visiting vehicles like the Cygnus cargo spacecraft. The common berthing mechanism is the installation port that Cygnus is guided into by robotics officers. There are hooks and latches to begin the process, and that is followed by the spacecraft being bolted into place. Here in Mission Control, the OSO mech, or the Operations Support Officer, directly oversees operation of that common berthing mechanism. This Cygnus will be installed into the Earth-facing port of the station's Unity module. One of the advantages of using a common berthing mechanism is that large equipment and cargo can easily fit through the opening. Just a short while ago, the Cygnus cargo spacecraft performed a final major burn to get the Cygnus cargo spacecraft into place, set for a robotic capture. The command to initiate this burn is sent by engineers in Cygnus's flight control room in Dulles, Virginia. We are in joint operations right now. This means that Mission Control Houston is working collaboratively with controllers in Dulles, Virginia on coordination of the burns and preparedness of the station crew to capture Cygnus for installation. And this is because the space station has an invisible boundary called the keep-out sphere.
Power cycle.
This keep-out sphere is a 200-meter radius, 200 meters in radius or 400 meters in diameter. You can get kind of a good view of that on your screen there. Sphere, perfect sphere around the space station, and it's one of the several safety zones for visiting vehicles like Cygnus.
Unit, I see green main power LED.
Copy, Satoshi. That's a good configuration.
So before moving within this keep-out sphere, Cygnus must be configured so that it would not cross that boundary for at least 4 orbits in the unlikely event that the spacecraft lost its maneuvering capability. Cygnus is inside 400 meters away from the space station, so there's a little bit of time before Cygnus reaches its next milestone at that 250-meter hold point. In the meantime, why don't we take a look back at how the spacecraft got here in the first place? Cygnus's journey to space began on a sunny Tuesday afternoon earlier this week. The spacecraft launched at 12:07 p.m. Eastern Time. That's 11:07 a.m. here in Houston on January 30th. Cygnus lifted off atop a SpaceX Falcon 9 rocket from the Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. It was an on-time launch for Northrop Grumman's 20th cargo resupply mission, and the first time a Cygnus cargo spacecraft has launched on a Falcon 9 rocket. You can see a recap of Tuesday's launch on your screen here. This is not a live view. The spacecraft went on to go through its post-launch milestones as planned. It separated from the Falcon 9 spacecraft with no issues and went on to deploy both of its cylindrical solar arrays a little less than 3 hours after takeoff. It's been making its way to the space station ever since. It went on to perform a number of delta velocity burns, some lasting up to 16 minutes, others lasting just seconds, all with the goal of fine-tuning the spacecraft's position in space to bring it to the space station. Mission Control Houston and the Northrop Grumman control room in Dulles entered joint operations, and about an hour and a half ago, both gave a go for another set of thruster firings. As you know, it did the approach initiation burn during our coverage today, and then another burn just a few minutes ago, and both performed nominally. So in addition to those 3 monitors with their camera views and data screens that they have, in addition to a number of controls right there in the workstation, they do indeed have what looks like a video game joystick. This operation is part of their astronaut training here in NASA's Johnson Space Center in Houston, Texas, where they can practice these controls in a simulated environment. But they also can practice at the real robotic workstation before Cygnus arrives to get a refresher on the controls while they're in space. And this is something that both Mogbelli and O'Hara got to do earlier this week on the station. We're now less than 1 hour away into our planned capture of Northrop Grumman's Cygnus spacecraft this morning, but it's important to note that capturing the spacecraft is just the first step in the process. Once Cygnus is in the grasp of the robotic arm, the astronauts have completed their job, but the work then continues. It turns to the robotics officers here in Mission Control Houston to install the spacecraft. They will control the robotic arm from here on Earth using a camera that's looking out the Harmony module's hatch window as a guide, among other tools at their disposal. They'll guide the spacecraft to its final position at the Earth-facing port of the space station's Unity module. Then they'll install the spacecraft into place, permanently securing the cargo spacecraft in place until its departure 6 months from now. The Cygnus vehicle is now within 300 meters of the space station. It's expected to get to its hold point in less than 5 minutes from now. We expect a call to the crew when this happens. So as Cygnus makes its way to the 250-meter hold point, Cygnus will seemingly stop in its tracks. But of course, it's not quite holding still. It's orbiting the Earth at thousands of miles per hour. But the rate that we're talking about is in relation to the space station. So it will not come any closer to the station than 250 meters. Like we talked about earlier, this is a good checkpoint before the spacecraft can enter the keep-out sphere. The keep-out sphere is 200 meters away from the space station, and it's an invisible safety marker. As long as Cygnus is outside of this boundary, we know that the spacecraft would not come any closer and damage the station if something were to go wrong. Flight Director Diane Daly in the room here with us in Mission Control Houston must give the go after polling her team before the spacecraft can begin to close in again.
Station Houston on space to ground 2 for a status for Cygnus. with you on 2.
And just letting you know that we're going to be here at 250 for a little longer. We're just doing some reconfig on one of the Cygnus radios.
Okay, we copy.
If you're just joining us, a Northrop Grumman Cygnus cargo spacecraft launched from Cape Canaveral in Florida on Tuesday, and now the spacecraft has arrived in the neighborhood of the space station. It completed a series of burn to get itself into the position that it's at now, the 250-meter hold point. So that's what you see on your screen there.
And Houston, from station, we still see the light within the corridor. The vehicle size is about 25% larger than the outline in monitor 1 and 2. The 1 and 3, sorry. The light is not offset from the circle it matches, and the circle is still offset from the corridor center, about 1 vehicle with starboard.
We copy, and we have no concerns. Thanks for the status.
Flight controllers are now making sure that the spacecraft is healthy and ready to continue moving into a position where it can be robotically captured. Flight controllers also made sure that the space station is ready to receive the cargo spacecraft, having pulled that the space station is go just a few minutes ago. And NASA astronaut Laurel O'Hara with you on the comms just a short minute ago, confirming that even though the space station is in an orbital nighttime, she is still able to see the lights on Cygnus and has a good visual of the spacecraft. She is ready to receive the arm. Excuse me, she's ready to operate the arm and capture the spacecraft. While the Cygnus cargo spacecraft was at the 250-meter hold point, engineers in Dulles noticed a slightly erratic behavior to a backup communication system that has now been restored. Teams pulled go to proceed, and the vehicle began its motion again. It's now proceeding to its next hold point at the 30-meter mark, and it's about at that point right now. We're estimating a capture time at approximately 4 a.m. Central, 5 a.m. Eastern Time. We'll then go off the air and continue our coverage at 5:30 a.m. Central Time, 6:30 a.m. Eastern.
Station Houston on Space to Ground 2. Confirm 30-meter hold and set up for capture per step 6 in 1.102.
Okay, station copies, and we see hold and range is 30 meters, and we'll perform step 3 of 1.110.
Good read.
The spacecraft has reached its next major milestone, holding at the 30-meter mark. This is about 32 meters on 32 yards on a football field away from the International Space Station. It will not proceed any closer until a go-no-go poll is conducted here in Mission Control and is about to begin shortly. The Cygnus cargo spacecraft.
Station Houston on 2 for Cygnus approach.
With you on 2.
Yeah, Jaws and Laurel, we have one delta that we'd like to make you aware of. So because we saw the transient earlier with the C2V2 loss of visiting vehicle heartbeat, we want you, as you are trained, if you get that alarm, to go ahead and back away, but just take a little bit of break to see if it goes back out of alarm before you send the retreat. How copy?
Okay, we copy. So in the back away cue card, line 8, if we see, and this only applies to the prime C2V2 loss of visiting vehicle heartbeat or all of block 8?
Good question. It's all of block 8.
Okay, for all of block 8, we will back away the arm and we will not send the retreat command right away.
Those are good words. Just a couple of seconds to see if it comes back out of alarm.
Okay, we copy.
Also, we'd like you to adjust the lab over the shoulder view. It looks like we came off the view there for a little bit.
Okay, I'll see if one of the other crew members can do that.
All right, Cygnus is ready to proceed to the capture point. Expect approach to resume shortly.
Cygnus is now within 200 meters of the International Space Station. It's difficult to see on your screen there. We've got kind of a data overlay, but the space station is in an orbital nighttime, so it's a little difficult to see.
Station Houston, Cygnus is inside the 200-meter keep-out sphere. Crew now has authority to issue an abort if no comm with MCCH and the light is outside the corridor.
Station copies.
The space station has an invisible boundary around it. It's in a spherical shape called the keep-out sphere, and that's at the 200-meter mark.
Station, we show range at 186 meters. Light is within the corridor. Can't see the vehicle size relative to the outline. The light is offset from the circle, a quarter vehicle with forward, and the circle is offset from the corridor center, about half a vehicle with starboard.
We copy, no concerns.
NASA astronaut Laurel O'Hara will use the robotic arm that you see on the left-hand bottom corner of your screen. That is the robotic arm in today's operation. It's called the ISS-ARM, or the Space Station Remote Manipulator System, or simply the Canadarm2. At the end of Canadarm2 is what you may hear referred to as a lee, or a latching end effector, which is basically the hand of the arm. Inside are latches and snares that can grab onto and capture a target. Today, NASA astronaut Laurel O'Hara is controlling the robotic arm with an assist from NASA astronaut Jasmine Mogbelli. You heard a brief conversation a minute ago between Capcom Alex Kanalenkos and our astronauts on some instructions that they see on their procedures today. And when O'Hara is ready, the latches will engage and grab on, and the latching end effector has a camera, so sometimes the view that you will see on your screen will be from the robotic arm itself, but we don't have those views just yet. The spacecraft is now within 20 meters of the International Space Station, making its way to its capture point. Mission Control will give one final go, no-go for capture. While delivering cargo is Cygnus's main job, it also serves an important function for the space station at the end of its mission. The astronauts on the space station cannot just go take out the trash wherever they want to. They have no shower and no washing machine for their clothes, so Cygnus is loaded with wet wipes, old clothes, gloves, food wrappers, anything that the astronauts don't want around their house. At the end of its mission, Cygnus burns up in Earth's atmosphere, essentially eliminating its onboard trash, so it's very great to have after all of the cargo is unpacked. The engineering team at the Northrop Grumman Center in Dulles, Virginia are conducting a go, no-go poll now. So NASA astronaut Laurel O'Hara is there at the controls of the robotic arm in the station's cupola. The spacecraft has a number of aids to kind of help her out. We talked previously about how the cupola has a number of data screens to kind of help inform O'Hara. She can also look at it. NASA astronaut Jasmine Mogbelli can give her another set of eyes as well. But there's another tool on the spacecraft itself. It has a grapple target that O'Hara can use to correctly position the station's robotics arm. So we can see it right now on your screen. It's a little in the distance. It's in the middle of your screen. It's a black bar, kind of parallel with the bottom of your screen. It's a black bar with a white line there. But that's not actually what she's going to be grabbing onto. O'Hara's goal is to grab the grapple fixture, or the pin, sticking straight out perpendicular underneath that black bar. The robotics arm's latching end effector, or its hand, has a special snare mechanism that can grab the grapple pin and firmly hold onto it. So that grapple fixture, the pin, is what O'Hara is aiming for today, while the grapple target, the flat white line, will help her.
Station Houston, confirm capture point hold for step 8 in 1.102.
Houston Station copies. Executing step 8 of 1.102.
The space station has moved into a configuration known as DSATS inhibited. Essentially, the space station has gyroscopes that help keep it in the correct position. And when Cygnus is being captured, flight controllers don't want the gyroscopes thinking that the space station's orientation is going out of whack, initiating those thrusters, so they're temporarily inhibited during this operation. Robotics officers reporting that the operation is going nominally. The robotic arm is going through the procedures to grab a hold of the Cygnus cargo spacecraft.
Jeder Tag ein neuer Blick auf die Welt. Nachrichten und Livestreams Tag und Nacht. Ein Kanal für einen klaren Blick. Wir zeigen alles, was du wissen musst. So funktioniert die Welt. Wir halten dich auf dem Laufenden. Mit Nachrichten rund um die Uhr. Blick auf die Welt, hier bei uns.